Learn about noise in angle modulation. So first we are going to see about some introduction, then effect of noise on angle modulation, threshold in angle modulation, SNR curve of angle modulation system, pre-emphasize and de-emphasize in angle modulation system, and finally the questions. So let's see the introduction. What is angle modulation? When frequency of a phase of the carrier is varied by the modulating signal, it is called angle modulation. The noise gets added to the amplitude of the angle modulated carrier, whereas the message signal is present in the frequency of the carrier. This makes the analysis of the receiver performance in the presence of noise complicated. Now let's go to the effect of noise on angle modulation. Now in the figure we can see the effect of noise on zero crossing of two frequency modulated signals, one with a high power and the other with a low power. It is clear from the figure that the effect of noise in a frequency modulated system is different from that of an amplitude modulated system. The effect of noise in the low power frequency modulated system is more severe than that in a high power frequency modulated system. Now in a low power signal, noise causes more changes in zero crossing. Now let's go to threshold in angle modulation. The noise power should be greater in order to increase the performance of the signal power or carrier power. So what is threshold effect? Threshold effect is the phenomenon that occurs when the SNR at the detector input decreases below a critical level. Below this level, the resulting output signal gets severely distorted by noise. Angle modulation system exhibits such threshold behavior. It has been verified experimentally that the threshold level for the input SNR is roughly 10 dB for angle modulation. Below this threshold, there are occasions when randomly varying noise may have instantaneous amplitude greater than that of the signal. When this happens, the demodulator output will undergo a sudden change in phase. These phase changes call themselves as click in audio transmission. The threshold effects are more prominent in frequency modulation or phase modulation than in angle modulation. Now let's see the SNR curve of angle modulation system. Now in this curve, we are taking baseband case as the benchmark. We know that in baseband case, output SNR is equal to gamma. Also, we know that in angle modulation, as we increase the modulation index, the output SNR increases. Now, at this point, suddenly it starts deviating from straight line curve. Now, as we increase the value of beta, the threshold becomes more significant as we go for higher values of beta in order to get a better performance. Now, the value of gamma at which the threshold occurs is large for the larger value than that the smaller values of bandwidth. Now let's go to pre-emphasize and de-emphasize in angle modulation system. Now pre-emphasize and de-emphasize helps us to improve the performance of all kinds of systems in noise. In this system, a message signal is passed through a filter which modifies the spectrum of the system. Now at the transmitter it will have a pre-emphasized filter, and at the receiver it will have a de-emphasized filter, so that the combined product of both is constant. Now in between we have a channel with transfer function at C omega and also a noise. So as a whole, we have power spectrum shape in the input system. We must have same power spectrum shape in the output system, so that the message signal remains undistorted. So now we have come to the end of our lesson. So let's see some of the questions that are need to be answered. In the angle modulation, the output signal to noise ratio is increased by decrease in receiver noise power explained. So here is the answer. A comparison of the preceding result with the signal to noise ratio in amplitude modulation, which shows increasing the transmitter power will increase the output signal to noise ratio, but the mechanisms are totally different. In an angle modulation, Any increase in the received power directly increases the signal power at the output of the demodulator. This is basically because the message is in the amplitude of the transmitted signal, and an increase in the transmitted power directly affects the demodulated signal power. However, in angle modulation, the message is in the phase of the modulation signal, and consequently increasing the transmitter power does not increase the demodulated message power. Thus, in angle modulation, the output signal to noise ratio is increased by decrease in the received noise power. Now let's go to the next question. Why noise power and output signals are unchanged? So here's the answer. We have seen that the output noise of power spectrum density rises parabolically with frequency. Practical message signals have a power spectrum density that decreases with increasing frequency. Hence, the noise is strongest in the frequency range where the signal is weakest. The pre-emphasized circuit does not increase the transmitted signal power because for frequency modulation, the transmitted signal power S1 is identical to the unmodulated carrier power. The noise power N9 at the demodulator input and the output signal power S0 are also unchanged. Now, the third question, that is, why threshold effect is not a serious problem in audio transmission. So, here is the answer. For voice and music transmission, SNR has to be in the range of 30 to 60 decibel, which requires the input SNR for considerably above the threshold level. As input SNR drops considerably below 30 decibel, additive noise will obstruct the signal completely, long before the multiplicative noise captures the signal. Thus, for audio transmission, threshold effect is not a serious problem. That's all for now. Thank you for patiently hearing.